morning, calculus students. Welcome to another day. It is Tuesday the 5th, and we just want to look, all I'm going to do today is look at a few more integrations. I'm just going to give you a couple more examples, and then you're going to have another assignment, this time out of your textbook, dealing with integration. Questions will get a little bit harder, a little bit more complex in terms of taking the integrals, so we want to get into that. And then later this week, what we're going to get into is some techniques for integration, which will allow us to integrate some of the bigger, harder questions where a derivative may have been taken using the chain rule or the product rule or the quotient rule, some of those things. But today we're just going to look at a couple of examples. So the first one's on the board behind me. You'll see that this is an indefinite integral, which doesn't change anything. It just changes the fact that we're not going to be putting numbers in at the end. We're not going to be getting a numerical answer. We're going to just get the equation for the integral. We're going to add c to the end, and that will be the end of the question. All right, so here we have the integral of 6x squared plus cosecant squared x dx. Now, this can be broken up. Okay, just like with derivatives, if we have the derivative of a sum or a difference, it can become the derivative of each individual piece. Same thing here. This could become the integral of each individual piece. You don't have to write this out in any sense, but we do need to do this in our heads when we're taking the integral of this. So we go ahead and start. We're going to just use our basic integration technique here, where we're going to go 6x, we're going to increase by 1 to make it cubed, and then we're going to divide by that number. So that's the integral of 6x squared, plus the integral of cosecant squared. Well, to find that, we will go to our handy formula sheet, this one that you have, and you're going to look down it, and you're going to see that integration rule number 9 is cosecant squared, and you will see that equals to negative cotan x. So plus negative cotan x. And that's it. We'll add c to the end here. And just to make it look nicer, we're going to simplify this. So 6 over 3 is 2x cubed. This becomes, adding a negative just becomes subtracting. And there we have it. All right, so nice and easy. Don't forget your formula sheet. We're going to do one more example on the other board, and then your assignment will be out of your textbook, and you'll find that on Connect. Here's our second example. So for this one, we have the integral of t squared minus root t minus 2 all over t dt. First thing you're going to want to do when you have a question like this is you're going to want to simplify it. This t is a common denominator under each of these three parts. So simplifying it means it's going to become, here we have t squared over t minus t to the 1/2 over t. Means we're going to do a half minus 1, which will give us t to the negative 1/2. And then we have negative 2 over t, which I'm going to make 2t to the negative 1. And then we still have our dt there. All right. Actually, in hindsight, we're going to go like that, because we have an integration rule that deals with something over the variable. All right, so now we will go and take the derivative of this, and so t becomes t squared over 2 minus, here we're going to increase the exponent by 1. And if we increase a half by 1, what do we get? We get t to the 1/2 divided by 1/2. We'll simplify that further in a moment. And 2 over t, again, if we look to our integration page, this one, you'll see integration rule number 3 is 1 over u. The integral of 1 over u du is the natural log of u. And so if I have 2 over t, it's going to become 2 natural log of 2. Just like, sorry, not 2. I would use the 2. It's natural log of t. Just like that. Of course, we're going to add a plus c to the end here. And the only thing we're going to simplify here to make this simpler is here we have a t to the 1/2 over 1/2, that's going to become t squared over 2 minus 2 square root of t minus 2 natural log of t plus c. Okay? But the key to this, again, is making sure that when you see something like this, you simplify it first. And then again, we need to use our integration rules. Here it's tempting to make this 2 times t to the negative 1. But that won't work out, because if you have t to the negative 1 and you try to increase that by 1, you're going to get 0, and then you have to divide by 0, and that doesn't work. So if you ever get to something like that, if you've made this 2t to the negative 1, you're going to realize that it's not going to work out, because you're going to have to divide by 0, and there must be another way to do it. Look to your formula sheet to get that answer. All right, you're going to get an assignment out of your textbook today. So check Connect for the page number and the numbers. And when we come back later this week, we'll be looking at what's called integration by parts, or integration by substitution. I can't remember which one we're going to do first. But we're going to do one of those. There's integration by parts and integration by substitution that we have to look at in the next little while. So have fun doing the assignment. If you have any questions, make sure you email me and ask those questions. See you tomorrow.